Hello students, welcome to my channel again, Elite Maths class. Today here I am with the fourth part of determinants classes. This is my fourth video. So if you are first time watching this video, you first go through the links of the previous video which is given in the description box. So here I am going to discuss or define what is adjoint or adjugate of a determinant and what is inverse or reciprocal of a determinant. For that, the concept of minors and cofactors and the others concept also are very important. So you first go through the links. Let's start. Here let us take del, a given determinant. I am starting with a 3/3 determinant. This is the given determinant a11, a12, a13, a21, 22, 23, a31, 32, 33. Now what is adjoint or adjugate? For that, first thing we have to know what is cofactor. It is already defined in my previous video, so you go through the links. Let Cij or Aij, it is denoted by Cij or Aij also, Cij or Aij be the cofactors of Aij in del. That means C11 is the cofactor of A11, etc. That means what is the cofactor of A12, it will be C12, cofactor of A13, it will be C13. Now let us form a determinant by using the cofactors of the given elements. Now say here I am forming a determinant. First element is C11. From this definition I have defined what is cofactors. C11 is the cofactor of A11. So here I have written C11, that means cofactor of this element. Here I am writing C12, C13, C21, C22, C23, C31, C32, C33, C33. Now see how this determinant is formed. It is just by replacing the cofactors, by replacing each element by its cofactor. That is, in place of this element you have to replace the cofactor of this element, in place of this you have to put cofactor of this element, and so on. So we are getting a determinant of order 3/3 also. This determinant, which is formed by the cofactors of each element, is called adjoint or adjugate, adjoint of del, or it is also written as del 1, is the adjoint or adjugate of the given determinant. So in a simple way, what is adjoint or adjugate? It is a determinant formed by replacing each element by its cofactor in the given determinant. Simple way, find all the cofactors and replace them in place of the respective elements. Then what determinant we got is the adjoint or adjugate of the given determinant. Now let us say what is reciprocal or inverse of a given determinant. This is also connected to this one, adjoint or adjugate. As adjoint or adjugate is connected to cofactors, cofactors is connected to the minors. Similarly, inverse or reciprocal is also connected to or defined by adjoint or adjugate of a determinant. So up to this, adjoint or adjugate of a determinant is defined. Now let us take del, the given determinant, be such that the value of the determinant is not equal to 0. If the value of the given determinant is not equal to 0, only then inverse of del or reciprocal of del exists. That means this is under certain conditions. In which condition inverse or reciprocal of a determinant exists? It is the condition when the given determinant is not equal to 0. Now see how to find out the inverse or reciprocal is defined. It is denoted as del power minus 1. Del power minus 1 means inverse of del, and it is defined as adjoint of del by del cube. This is the definition of inverse of a determinant. and this del cube, it is for order 3. This definition is for order 3, and del inverse equal to, it will be adjoint of del by del square, it will be for a determinant of order 2. So this is the definition of inverse or reciprocal of a determinant of order 2. The definition is same, but simply whenever it is order 2, then we have to divide adjoint of del by del square, and when it is of order 3, then we have to divide adjoint of del by del cube. Now see, what does it actually mean, the definition of del inverse? See here, del cube means what? It is the value of the determinant. So del inverse will be, now see what is adjoint of A? Adjoint of A is this one. Now what to do with del cube? In my second video, properties of determinants are discussed. One property was scalar multiplication of a determinant. Scalar multiplication of a determinant means, see, if this determinant is multiplied by any scalar k, then k will be multiplied through any row, through all the elements of any row or all the elements of any column. That is, the scalar will be multiplied to either a row or a column. So here it is also this one we can consider as the scalar del cube. So what is the adjoint? C11, C12, C13, C21, C22, C23, 31, 32, 33. So this is a scalar. As we know that scalar is to be multiplied either in a row or in a column. So this is equal to, we can write C11 by del, C12 by del, C13 by del, C21 by del, C22 by del, C23 by del, C31 by del, C32 by del, C33 by del. That is, how many 1 by del are there? 3. So 1 by del is multiplied through first row, 1 by del is multiplied through second row, and another one multiplied through third row. In a similar way, say if you want to take common 1 by del from the first row, here will be 1 by del, another 1 by del from second row, another 1 by del from third row, so there will be 1 by del cube. So this is the scalar multiplication property subject to the condition del not equal to 0. Now see why this condition is necessary. Here, according to the scalar multiplication of a determinant, we can divide each element by del. So if del is 0, then each element will be undefined. That's why the condition is very necessary for defining inverse of a determinant. So this is the definition of inverse of a determinant. That is, what is the definition? It is adjoint of del by del cube. Del means the value of the given determinant. So hope this is clear. Now let us see with an example. Now let us see how to find adjoint or adjugate and inverse or reciprocal of a determinant with this example. I have taken a 3 by 3 determinant. Say this is the given determinant 2, 1, 3, 4, minus 1, 0, 3, 2, 1. Now we have to find adjoint and inverse or reciprocal of the determinant. The first thing you have to do is to find the value of the determinant. This is by expansion of the determinant, by Laplacian expansion, which is discussed in my first video. Now the value of the determinant is 27, which is not equal to 0. That is, del not equal to 0. This is the necessary condition. To find reciprocal or inverse, we must have to del not equal to 0. So this condition is satisfied here. That is, we can find inverse of the given determinant. Second thing, before finding inverse, we have to find the adjoint or adjugate of the given determinant. For that, what we have to do? We have to find out cofactors of all the elements. Now see, by the definition of cofactor, what will be C11? Here you must have to remember the sign of the position, plus minus plus, minus plus minus, plus minus plus. I have shown in details first three. The first one, cofactor of 2, 2, that is, this position element is written as A11. So what will be the cofactor of? This is C11. So what will be C11? you have to take the sign of this position, this is plus, then you delete the row and column in which the element lies, that is the first row and first column. Then what remains? These 4 elements you have to write in a 2 by 2 determinant, minus 1 0 2 1. The position of the sign of the position is plus. Now expand this determinant, this into this, minus 1 minus 2 into 0 0. So what is the value? It is minus 1. So cofactor of the first element is minus 1. Now C12 is this element. Now see, position of this sign of this position is minus. I have written minus first, then you delete first row and second column, that is in which row and column the element lie. Then what remains? These 4 elements, 4 0 3 1, 4 0 3 1. Now expand, it will be minus 4 minus 0, sorry 4 minus 0 and a negative sign here, so the total value will be minus 4. Now see the third one, this element, it is A13, so the cofactor will be C13 and position sign of this position is plus, so plus here. Now you delete first row and third column in which the element lie. Now what remains? These 4 elements, 4 minus 1 3 2, 4 minus 1 3 2. Now expand this, 4 2s are 8, minus minus plus 3, that is 11. So this is the cofactor of this element, that is A13, and it is written as C13. In a similar way, these are the cofactors of the other elements. Exactly in this way you find all the values. So all the cofactors we have found. Now what was the definition of adjoint or adjugate? See here, adjoint. Now first we are finding adjoint of del. Adjoint, the definition of adjoint of a determinant is just replace every element by its cofactor. Here we have all the cofactors. What is the cofactor of this element? It is C11. See, value of C11 is minus 1. Now what is the cofactor of second element? It is minus 4. Write it in place of 1. Next, what is the cofactor of third element? It is 11. Now what is the cofactor of this element? C21, it is 5. What is the cofactor of this element? C22, it is minus 7. Cofactor of this one, C23, minus 1. Cofactor of this element, 3. Then cofactor of C32, it is 12. And the last one, it is minus 6. So this is the adjoint or adjugate of the given determinant found by just replacing each element by its cofactor. So this is the adjoint. Now the second thing, how to find inverse or reciprocal of the given determinant. Now see the definition first. Now del inverse equal to, the definition was adjoint of del by del cube. Now what is the value of del cube? Del is 27, so we may write it is the value of the del 27 cube. Now you just put the value of adjoint of del. This is minus 1, minus 4, 11, 5, minus 7, minus 1, 3, 12, minus 6. Finally, del inverse equal to 1 by 27 cube. 1 by 27 cube means 19683 into del, that is the adjoint of the given determinant. It is minus 1, minus 4, 11, 5, minus 7, minus 1, 3, 12, minus 6. This is the value of inverse of or reciprocal of the given determinant. You remember one thing. Now see, the value of del cube is 19683. It is a large number and we can't divide all the elements of the determinant by 19683. So don't divide, leave it here as a scalar multiple. So this is the answer of the given question, that is the inverse or reciprocal of the given determinant is this one. So hope how to find adjoint or adjugate of a determinant and how to find inverse of a determinant is clear. In my next video I will discuss how to find the product of two determinants, or how the product of two determinant is defined. And the another thing is very important concept, operations on a determinant. These also will be discussed in my next video. So keep watching. Thank you very much.